All right, so we've got 13.1, using trigonometry with right triangles. I'm getting used to writing on the iPad, so if you have any issues reading anything, just shoot me a message and let me know about that. So, I don't know, if you think back to geometry, maybe you loved it, maybe you hated it, maybe you liked trig, maybe you didn't, I don't know, but that's what we're doing for the next 2 chapters. So we've got 6 trig functions, of angle theta. So we've got sine of theta, which is equal to the opposite over the hypotenuse. Okay, so opposite OPP over the hypotenuse, which is HYP. That's how I'm going to write it. And then we also have adjacent as an option. So for cosine of theta, we've got adjacent over the hypotenuse. Okay, and then we've got tangent of theta, which is opposite over adjacent. Okay, and then each of these have buddies that go with them. Okay, so the buddy that matches up with it with sine is cosecant of theta, which is hypotenuse over the opposite. Okay, so they're inverses of each other. Okay, and we'll look at that in just a second. Okay, secant of theta is hypotenuse over adjacent. Okay, and it's buddies with cosine. And then cotangent of theta is adjacent over opposite, and it's buddies with tangent. Okay, so I mentioned that they are inverses, so what do I mean by that? So what I mean by them being inverses is that cosecant, help if I could click the right thing, cosecant of theta is equal to 1 over the sine of theta. Secant of theta is equal to 1 over the cosine of theta, and cotangent of theta is equal to 1 over the tangent of theta. Okay, so that is what I mean by inverses of each other. There with that. So we did some review in the worksheets about looking at an angle and it asking you what the sine, cosine, tangent, and stuff like that was. So we'll get a little bit of that, and then also a little bit of finding the cosecant, secant, and cotangent of each of those with that. But for the moment, we need to get some trig values for special angles, and we will have these special angles given to us on the unit circle, which I've mentioned a little bit before previously, just kind of giving you a heads up about it, but we'll actually get into the unit circle in another section or two. But in the meantime, trig angles for special angles, or I guess really what I should say here actually is trig values for special angles, are not really the angles. The angles that we need to be aware of are 30 degrees, 45 degrees, and 60 degrees. Okay, so if you remember special triangles from geometry, then perhaps you remember that we had two special types of triangles. Maybe think back to what you think they might have been, if you remember them. Okay, and we were told that, obviously you have one that's a right angle, so that would be obviously a 90-degree angle. The special types were a 30, 60, 90 triangle. That 30 looks a little rough. See if I can rewrite it. Or not. 30, 60, 90 triangle. And then this other one was a 45, 45, 90 triangle. Okay, so the values that went with these, we had for the 45, 45, 90, it was 1, 1, square root of 2. And then for the other one, the 30, 60, 90 triangle, it was 1, 2, and root 3. Okay, so that was the special triangle. So I'm going to create a table here. To bear with me, I'm going to try to make it look really nice and neat. So y'all get to see my trick for how I make this work now. We'll just go out here. You'll need 1, 2, 3, 4, 5, 6, 7 columns and 4 rows. I'm just going to jump in the video to where I have the table complete. All right, so in this top row, we're going to have theta, sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. And then we're going to have 30 degrees, 45 degrees, and 60 degrees in here. So we're going to get the values for each of these things, starting with 30. So the sine of 30 degrees is 1/2. Okay, and this is just coming from these special triangles here. Okay, that's all where I get it from. So I wrote them out first. Okay, cosine of theta is root 3 over 2. Tangent of theta is 1 over root 3 if we just were to read it right off, but we want this rationalized, so we're going to call it root 3 over 3. Okay, so this one, let's see, circle it in orange, I guess, maybe. This is the one that we will use, so that's the one you're going to want to be familiar with. Okay, cosecant is 1 over sine, so that's just going to be 2. Secant is 1 over cosine, so that's going to be 2 over the square root of 3, which again we want to rationalize it, so it's going to be 2 root 3 over 3. So again, we would be using this one that's rationalized for us. And then lastly, for cotangent of 30, it would just be 1 over tangent, which would be root 3. So we would want to go back and use the 1 over root 3 for that part. Okay, so for then the 45, so the sine of 45, again, I'm getting these from the special right triangles here. So this one goes with this. The 30-degree angle goes here, and then the 60-degree angle will go with this column. Okay, so the 45s, the sine of theta is 1 over root 2. Again, we want it rationalized, so it's going to be root 2 over 2. Okay, meaning that the root 2 over 2 is the one we will use. Okay. Cosine of theta, or cosine of 45, is also 1 over root 2, or root 2 over 2. I might go back and just circle all of these at the end, but basically this is the one we're using here. The tangent of 45 is 1. cosecant of 45 is, again, we want to use the 1 over root 2's for sine and cosine to do cosecant and secant, so it's going to be root 2, and this one is also going to be root 2. And then lastly, for cotangent, it is also 1. Okay, and then jumping down and doing the 60-degree one, sine of 60 is root 3 over 2. Cosine of 60 is 1/2. Tangent of 60 is root 3. Okay, so then cosecant is 1 over sine, so it is going to be 2 over root 3, which is going to be 2 root 3 over 2. And so, again, we're using this one. And then secant is 1 over cosine, so that's 2. And cotangent is 1 over root 3, or we rationalize it to be root 3 over 3. And again, we are using this one here. Okay, so we will be using all of this to do examples in class. Again, not sure exactly how long it will take us to do that, but just wanted to give you that refresher. And then one other thing, just as a review that I forgot to mention but could come up again, I hope you know that by this point about the Pythagorean Theorem. You should have learned this in Algebra 1, geometry, you should have used it a lot. And so now it's just coming back in case you're not given one of the side values. You'd use a squared plus b squared is equal to c squared for that. So, anyways, that should be all for this section of notes, and then we'll just get into a bunch of examples during our live video tomorrow.